So the first thing we're going to do will be to implement this model in Excel. Okay, and we did have this investment problem formulated last time, and this shows the complete model. To save some time, I already put those data in this spreadsheet, so you don't have to input it. So these are the data I put, so that's the 3.9. And just briefly review what we implemented. So this is that investment problem that the client of investment company is trying to maximize the return from 6 different bond issues. Okay, and they had some constraints. For example, like any of them should be no more than 25% of the total money invested, the long-term ones, the high-risk ones, and the sum need to be this much. Okay, so now let's go to that Excel. What I inputted here, this table here, are basically what you see from that problem statement. Okay, so from that problem statement, these are all given. Okay, and we know that the decision variables. Okay, so first I'm going to insert a column here to reserve those cells to be my decision variables. Okay, remember those decision variables? How much to invest in each of those bonds, right? So since all those bonds are listed here, so a natural place to put the decision variable will be here. Okay, and we'll shade them in yellow and give it a meaningful label, a heading. So money, amount money to invest. So these will be our decision variables, the ADEMOS. Okay. Then let's go back to look at our objective function. Our objective function is to maximize the return. Those are the sum product of our return rate and the decision variables. Okay, so we go back to see the total return, and we have those return rate here. And we know that the objective function would be just the sum product of this column and this column here. Okay, and I'll put it here, total return equals to be sum product of this column and this column here. Okay, highlight this in blue so we know that's our objective function. Okay, so we took care of the decision variables and the objective function. Now let's check. The first constraint represents the one that's no more than 25% should be invested in any of the investment. Okay, here in this slide, I put all the constraints in like one formula. But remember when we formulated in class last time, we had 6 formulas, right? So that's A less than equal to 25% times this 750,000. So we have one for each. And so we have the left-hand side here, right? The A through S here. We need to have these 6 formulas here. So we have the 6 left-hand side. So it's natural we just create another column here to be the right-hand side. So when we go to define the constraint, we can have just like this entire column being the left-hand side, less than equal to then another entire column, the right-hand side. Okay, so for that, I'm going to insert another column here and change the, oops, sorry, not the entire column. Okay, so that will be, and in this column, what I want to calculate is the 25% multiply, that's 750. Okay, 750,000. So instead of put here, okay, so equals to be 0.25 times 750,000. Instead of putting this way, we said we don't embed those numerical values in the formula. Okay, so I want both number to be somewhere. Okay, so instead of this way, I'm going to put here. Okay, so maximum percentage. Okay, and here I'll put 25%. So later I can refer to this cell in my formula. And I do need the other 750. Okay, so here first I'm going to move this. I'm going to put that 750 here. The total available. That's the 750,000. So why I put it here? Because that's the sum of this entire column. So we said that things that are logically related need to be physically related. So I put this value here. Okay. Then here I'll just put the formula that equals to be this 25% multiply this 750,000. And I'm going to copy this formula all the way down. And I don't want either cell to be shifted when I copy it. So click in it. Then you can just press F4. Okay, so here also click F4. So the dollar sign will appear on both the row number and column number. That means the entire cell is fixed. Okay. Now you can copy this formula all the way down. And that's my first constraint. That's the right hand side. So I just shaded this one here. I'll shade it in this way. I shaded it so that I remember there is one constraint here. Okay, so we took care of this first constraint setup. Second, do you guys remember what are these representing? Okay, so these represent the long-term bound. Those are the long-term bound that matures more than 10 years. Okay, so that's A, D, M, and S. So one way we can do is put a cell and you don't need to follow here. Put a cell and make it equal to A plus D plus M plus S to be the left-hand side of that constraint. And then put another equals to be 0.5 times this 750 here, and then make it one constraint. Okay, so that's one way to do it, but that's not the preferred way. Okay, because we want our spreadsheet first, you can trace it back. To know what are included here, you have to click inside, say, oh, that's the sum of these ones. So that's not preferred. Second, we want our spreadsheet to be modifiable. For example, later, say, another long-term bound, and one of those bound, say E, become long-term bound too. Okay, it matures more than 10 years. Then you have to go click inside this cell and click, okay, let's add one more here. Okay, we don't want to do this. We just want, okay, once there are changes in those maturity year, I just come here, change this to 10 years. Then my model will be automatically updated. Okay. So let me go back. So what should we do? We're going to put insert a column here to say, okay, is it long term or not? And we'll use 1 to represent yes, and 0. Oh, sorry. 1 means yes, and 0 means no. Okay. Or you can put, I use like 1 equals to be yes, and 0 means no. Okay, and then I guess most of you know there is an if function in Excel. So you can just type here to be if. So there should be a logical test. Logical test will be if this value is greater than 9, which means greater than or equal to 10, okay? Then output is 1, means yes, it's a long-term bound. Otherwise, 0. Okay, so in this way, we create a formula that first can be copied all the way down. Second, you can modify just the value in the years to maturity, and it will be, you don't need to change anything here. Then you can see, okay, this is mature in 11 years, it is a long-term bound. Then copy this formula all the way down. Click inside to check whether it copied correctly. Okay, so it looks at this value here. If it's greater than 0, then return 1, otherwise return 0. Okay, and we do see there are 1, 2, 3, 4 long-term bounds that corresponds to A, D, M, and S.
Wouldn't we want to define what we consider long-term?
Okay, so those are the long-term ones, and so instead of putting, so this equals to be this plus 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 plus, here we're going to put total, long-term total. Here, we can just use that the sum product function again. Okay, yeah, so another good thing of using this 1, 0 is that you can cancel off those short-term bounds when multiply this value to this 0 here. Okay, so you put sum product of the decision variables and those 1, 0 value here. Then you are just summing up those long-term ones because they have a coefficient of 1. And the other ones have coefficients being 0. And that 0 multiplied this decision variable will cancel that value off. Okay, so with this function, we calculate the sum of long-term ones. And going back to that constraint, we know that the sum of the long-term one should be greater than or equal to 50%. So let's put so it should be required, and this value should be that 7,000 times required. Just put 50% here. And use this value here to multiply 50% to get half of this 750,000. Okay, so that gives you that value. So later we know that, so that will be the left-hand side, this will be the right-hand side of that constraint. Okay, so that takes care of the second constraint. Now the third constraint are the ones that are riskier ones. Should be no more than 35%. Okay, and the risky ones are defined using the rate. Okay, if we go back to the problem statement, see what they talk about here. Okay, represent the highest risk if they were rated lower than a very good. So if we check lower very good, so very good is a 1. That means if they get a rating here being 2 or 1, because 1 is excellent and very good is 2, good is 3. Okay, So that means for any of those bounds that the rating is greater than or equal to 3. So it's this 3, 4, 3. There are 3 of them. Okay. So let's just define that. So with this setup here now, I want you guys to set this column yourself. Okay. So would it be risky or not? So 1 means yes, 0 means no. Okay, so those are the riskiest ones. So the formula would be if this value here is greater than 2, then yes, otherwise no. Okay, so you can see that D, E, and O are selected. That's the same with what we put here, D, E, and O. Okay, so the formula is if this rating value is greater than 2, return 1, otherwise return 0. Okay, so here would be total of high risk bound. Then you can just do the same thing, sum product of your decision variables and your 0, 1 column. To add D, E, O together. Okay. Then here we'll say allowed. So required here means at least, and allowed means at most. Okay, allowed 35% here. So I'll put this equals to be this 750,000 multiply this 35%. This gives us the right hand side of this constraint. Sorry. Use this. Okay, so this takes care of the third constraint. Then we have our fourth constraint, which is the sum of all of them need to be 750, which is pretty easy now. So we'll just find a place to calculate the sum of all of them. So a good place would be here. And I'm going to move this down. So this can be used as our right hand side of that constraint. Okay, so here would be total invested, and that is the sum of all the values here. Okay, then I'm going to highlight these as my constraints. Okay, so I'm going to delete these two cells that I use just for demonstration purpose. This is the sum of the decision variables. So that's the left-hand side of that constraint. So what's the actual amount you invest? And this one, you just put the total sum. Yeah. And these two cells represents the left-hand side and the right-hand side of this constraint here. Okay. Okay, so then the last constraint is the non-negativity, and we know we can just check that box in the solver window. Now with this setup, we're going to go to solver to define it. So go to your add-ins. Add your variables. So all those yellow shaded cells are the variables. Click OK. Okay, so now the decision variables are already selected. Oh, sorry, objective. That's here. And make sure, okay, this is maximization, so default, that's correct. Then add the constraints. So we know that the first constraints, first group of constraints are these ones. Each of them need to be less than or equal to the 25% we calculated here. Okay, so that's the first constraint. Click Add. At the second constraint, what we did is the long-term ones. So the long-term ones need to be greater than or equal to, because it's required. You have to have at least 50%. So make sure you change the sign. Right-hand side. Okay, second constraint done. Third constraint. High-risk ones need to be less than or equal to 35%. Calculated here. Then add another one. Total invested need to be equal to 750,000 here. Okay, so this model we implement the one that we assume we invest all the money. Okay, so once you're done, click OK. Make them non-negative. Change your program to standard LP. Okay, make sure you don't miss this last step. Simplex. Okay, and then solve. So if you get the same, then just do some cosmetic work. For example, put this say bottom border through all the and here. Same here. Okay, and then I would highlight these using bold. Same here. And I'm going to put a border, put a special border around my decision variable, the objective function. And these ones, bold. These ones, bold. Okay, and for those values that represent currency, I'm going to change this setting to currency. Same here. Okay, good. So highlight all of them. Go to number, currency. Click. See, there are a lot to learn too for Excel itself. Okay, here. Okay, so I'm going to put all of them to be middle, the alignment. Okay, and clear here like this is not shown, so I'm just click here. So the entire heading is shown. And yeah, so that's the model for this problem. Okay. So the main thing we talk about is to use those the if function to represent this one long term or not, high risk or not. Use 1, 0 to represent, and the benefit of that is later we only modify here, and we don't need to define other places. And also those 0, 1 value gives us enable us to use the sum product function to add just those values that we want, using those zeros to cancel the values that we don't need to add to the total sum. Okay, and here, yeah, these are all bold, so about this. Okay,